Hi, I'm James Pitts, and I'm the head of materials here at Big Wrap. Today we're going to talk about PA12CF and high-temp CF and the many benefits of carbon-filled filaments. So we're going to talk about the many benefits achievable through the addition of carbon fiber to a filament. So one of the major ones is improved strength and stiffness. Through the addition of carbon fiber into your parts and our filaments, you're able to make stiffer parts. That increases the Young's modulus of a part, and that basically says how stiff a part is, how it reacts to loading. That enables you to make things that can be smaller, yet maintain the same strength you need. Smaller parts, thinner parts, meaning the printing time is shorter, so you're quicker to your application through the use of these carbon-filled filaments. The heat deflection temperature of a material tells you how it's going to respond at elevated heat, right? So normally, most materials get softer as it gets hotter. Through the addition of carbon fiber, you can increase that level. So basically, it's going to be stronger at elevated temperatures. You can see an increase in the surface of the durability. So it's basically more resistant to wear. So if you have two parts rubbing or some sort of mechanism moving with the part in the assembly, carbon-filled parts can provide increased lifetime, basically. They basically last longer because they're not being worn away. One of the benefits of adding carbon to your filament and to your 3D printed part is the reduction of the layer lines. So you get a better overall appearance. There's better surface quality of your part, giving it better haptics. If you want to have that smooth surface, there's less need to post-process it and get your part out faster, looking better. So what can cause warpage or changing of shape, of ripping off the bed? As you're laying down plastic, it's warm. And warm things expand, and cold things contract. So as you're adding warm layers, they're cooling off. As you get higher and higher up, basically that contraction will rip the part off the bed. Through the addition of carbon fiber, that contraction is less pronounced. It gives the material kind of space to adjust itself without having to rip off the bed. It's silly, but I think of like adding rubber bands to a watermelon, and I can keep adding them, and I can keep adding them, and I can keep adding them. And as long as that surface, that print surface is strong enough or it holds, there's no problem. But as you add too many of those rubber bands, it rips off. And to minimize that, the addition of carbon fiber can make a more complex part. You can have a longer part. You have less problems trying to get it to work. Basically, it's easier to use through using this technical product. In order to get the most out of carbon-filled filament, there are a couple of requirements or tips and tricks you'd like to work on. So first and foremost, because of its kind of abrasive nature, it is important to have a hardened steel nozzle or just replace nozzles more regularly. It's something to maintain. Another thing is the addition of carbon fiber can lead to a more brittle product. And that's something you can just design around. That's the difference between having like my cup here, where it's very, very strong, but if I were to drop it, it would shatter, right? So it's being able to use these materials for their appropriate applications. So you get that stiffness, you get that strength, but you need to design things in such a way that they're not being impacted upon or slammed kind of thing. It'll kind of shatter, right? And that's okay. There's other materials that you can have in a multi-part assembly or even dual extrusion where you can kind of tune each part of an assembly to get the most benefit from that material. One important factor to keep in mind when designing your part or how you're going to orient it in the printing, the addition of carbon fiber does increase the kind of tensile strength, so in the direction of print, but there can be, if not managed correctly, a reduction in the layer adhesion. What does that mean? That means you need to be able to design or create your part in such a way to take the most benefit of a material or system. I always like to think about in carbon fiber. You see carbon fiber, regular carbon fiber, right? You don't see it in compression. It's not good at compression. Carbon fibers are good at tension and pulling. So by orienting the part in the direction of the stress or the load, you can greatly increase the effectiveness. Now, if it's counter to that in that Z direction, as we know FFF printing is weaker in that direction, this just is a little bit more so. So it's something important to keep in mind when designing. Currently, we have 2 carbon-filled filaments at Big Rab. There's PA12CF, it's a nylon 12, and we have high temperature CF, high temp CF. It's a bio-based polymer. The key differences, I would say, between these 2 carbon-filled filaments is the high temp CF has less demanding hardware requirements, so it's applicable for across multiple printing. The open format of the one, the Studio, it's no problem on the Pro, but again, it's kind of less demanding as far as hardware. So PA12CF has higher mechanical properties, has higher HDT. It's overall much more and solidly in the industrial side of mechanical properties. Not to say that high temp CF doesn't, it's just a little bit less. So if you want the most performance, that would be a PA12 product you'd want to produce. Although specially formulated for large format printing on a Big Rab, these materials will work well on any 2.85 millimeter open printer. So let's talk about some applications for carbon-filled filaments. In order to take advantage of that strength, in order to take care of that rigidity, often a common application we've seen is the manufacturing aids. So jigs and fixtures. The ability to make a part, to hold your part when you're milling. You want it to stay stiff. You don't want to be drilling or cutting or polishing and have that fixture change shape. You can maintain better quality of your part through taking advantage of that stiffness. Now, having it large format, having it less prone to warpage can enable very quick turnarounds for creating those often custom low quantity applications, those parts you're gonna make, because every part could be different in your shop. And the ability to rapidly switch from something that is more curvature or taking advantage of, say, the improved surface quality of carbon fiber and really open up the space in the automotive, aerospace. We've seen drones, we've seen so many more and more every day through the use of carbon-filled filaments. Consumer products are more and more taking advantage of these advanced products, these advanced materials like carbon-filled filaments, due to the ability to have increased surface quality, to have true customization. So unlike traditional mass production methods, 3D printing, especially large format 3D printing, enables you to make large parts that are very complex, that can handle with very small part runs or very complex geometry, and taking advantage of the reduction in warpage, the increase of strength, increase of stiffness, enables your parts to be operating at a higher level, right? And being able to take advantage of that complexity in ways that we're only now learning how to utilize fully. Another application for carbon-filled products or carbon-filled filaments such as PA12CF and high temp CF is molding. So taking advantage of that stiffer, smoother, stronger part enables you to make molds or make your mold last longer so you don't have to print as many parts, effectively reducing the cycle time and increasing the amount of final product you can put out. So today we talked a lot about the benefits of carbon-filled filaments such as PA12 and high temp CF. And if you want to learn more, please contact us at bigrep.com and we can find solutions. We can entire manufacturing solutions fit to your needs to get your parts the way you want them to be.